Okay, turns out section 5.1 needs a part 3 to get the last problem done. But this problem is a classic, so I wanted to be sure to do this one completely for you. So remember, it was your job to finish number 11 and then double check it on the answer key. So let's read number 12. Julie and Eric row their boat at a constant speed 32 miles downstream for 4 hours, helped by the current. Rowing at the same rate, the trip back against the current takes 8 hours. Find the rate of the current. Okay, so when it seems confusing, start with a table. So I'm going to say rate times time equals distance. We know that's true. Okay. Now, they're asking me to find the rate of the current, but there's something else that I don't know. So I'm going to let C equal rate of current. But the other unknown is their rowing rate. So I'm going to let R be the rowing rate. That's how fast they row no matter what, no matter if there's current or not. Okay? So let's do our two cases here. There's downstream and there's upstream. So let's read it again. When they row 32 miles downstream, 32 miles is a distance, downstream for 4 hours is a time, helped by the current, rowing at the same rate, the trip back against the current takes 8 hours. That's a time. What's the distance back? Well, it's also 32, or else they're not back to their car, right? Okay. Find the rate of the current. Well, now let's figure out how to fill in this rate column. If you ever go out on a river, and you know, right here we have a river you can go out on, and you have rowed or tried to swim out there, you know that there's how fast you can row. And if you're going downstream with the current pushes you along and makes you go faster. And if you've ever done that, this is really fun, right? You really feel like you're strong rowing that boat, okay? But when you turn around and go back upstream, there's how fast you can row minus the current slows you down, okay? And that is really hard, and your arms start to hurt. So now I create my two equations by just multiplying. So my first equation will be 4 times R plus C, I just wrote it in a different order to make it look pretty, equals 32. That's rate times time equals distance. Let's do it for the second case. 8 times R minus C equals 32. That's again rate times time equals distance. Now we're going to solve it. Okay, now I'm going to show you a shortcut to solve this. So let me turn the page over and make sure I copy it down correctly. So what did we have? 4 times R, was it plus or minus? Plus C equals 32, and 8 times R minus C equals 32. Okay. So there we go. Now, if the 4 and the 8 weren't in the front here, I could just add down right now, couldn't I? Okay, so what I can do is I can get rid of the 4 and 8 now. When I look at this first equation, this is 4 times this factor in the parentheses equals 32. This is just a multiplication problem. 4 times something equals 32. Therefore, I can divide both sides by 4, and I will get R plus C equals 8. See? Okay. I can do that same thing with that second equation. This is 8 times the parentheses equals 32. So if I divide both sides by 8, I will get R minus C equals 4. And now when I add down, I get 2R equals 12. Therefore, R equals 6. But that's not what they asked me for. Remember, R was the rowing rate. So you got to go back and figure out what the current rate is going to be, the rate of the current. And you should get 2 just by looking at these two equations here, right? If I have 6 plus something equals 8, that something better be 2. And you write the beautiful sentence. The rate of the current, oops, you can't read that, is 2 miles per hour. Don't forget your units. Alrighty, that is section 5.1.